Hey, what's up everyone? It's Tamimi from Solace. If you missed out on our first episode of the Solace Community Lightning Talks, don't worry about it, I've got you covered. The third talk featured Daniel, another developer from the community, who uses a Python-based front-end dashboard to represent a stream of data coming in using Solace. Check it out, and don't forget to leave your comments and discussions on our community thread on Solace.community. I will be introducing our next speaker, Daniel. Daniel, how's it going?
Hi, good, thanks. How are you?
Good. I'm doing well. Thanks for joining us. Where are you joining us from?
I'm in Coquitlam, which is a suburb outside Vancouver, BC.
Okay, perfect. We have a couple people from Canada, Ottawa, in the chat, so we could see it as well. So anyone who's joining us right now, feel free to let us know where you're joining us from, and we will be highlighting that. So Daniel, I kind of did a quick introduction about what you will be doing and presenting. For the audience who are joining us right now or on the stream, at Solace, we have released in beta version a stream of real-time events that gives you updates for New York City taxi data, and we're continuously developing on that. So what I did previously is gave Daniel access to the stream to kind of see what kind of data analytics you can do on this data stream. So Daniel, I will be sharing your screen shortly to kind of have a conversation about what you did and the project that you did. And I'm kind of curious to see what are the kind of things you did from a data analytics perspective with this stream of real-time data. So this is your screen already shared, and let us know what you have.
Okay, sure. So at kind of a high level, this if you're familiar with any business intelligence tools, this looks a lot like a Power BI or Qlik Sense dashboard. However, the data coming into this, as Tamimi mentioned, is live. None of this is sourced from a database. So this is all connected to a Solace stream of data. So the tools basically just involved with this. On my end, this was purely written in Python, but basically the visual part of this was written with the Bokeh library. So the Java, you see JavaScript here, but I wrote it in Python. That library converts it for me to save a lot of time for just making this prototype. But on the kind of the engine and the data analytics side of this, so basically we've subscribed to the event-driven architecture that Solace provides. We connected using Python's MQTT libraries, so we can receive MQTT messages like their taxi data demo provides. So what we did was we basically routed these messages into Python data frames, which are similar to an SQL database, except it's all in memory. It's a similar table row format, but the kind of events of messages coming in allow us to basically append to these data frames stored in memory, and then trigger an event to calculate rolling averages, and then basically start filtering on things, dividing into categories. So what you can see on the screen here is by kind of ingesting and processing the MQTT message headers, we can get real-time plotting using the Google Maps API of where these taxis are on the map in real time, get all of the information in real time, like the heading and speed. So all these little images are being rotated based on their real-life headings. We can get the current number of active drivers for at least a subset, and then divide in real time what type of vehicle we have, the 1 minute rolling average speed between all taxis. And yeah, so we've got KPIs here, which are calculated off the Solace data that's being aggregated and calculated on. And then we've also got plots that are coming in real time. And the tools Bokeh provides are pretty in-depth. So this tool comes with a lot of bells and whistles. So in real time, you can kind of see how much money all your taxis are making at any given time. So this is the meterage increment on a 5-second rolling average across all your taxis. So you can see at this point, a bunch of them were idle or something, and then a bunch of them picked up, and all kinds of cool insights you can get visually very quickly instead of looking at an insane stack of data in a database. So we've got like 10-minute rolling speed here. You can zoom in and get more fine granularity here. I can even update this. This is currently updating on about a half a second loop. I believe Bokeh can support down to 10 milliseconds. Probably not necessary for this demo, but it's possible. But yeah, the event-driven architecture of basically things like Solace, Confluent, but in this demo we're using Solace, allows kind of like real-time aggregation and calculation of streaming data. So none of this data is actually stored. Like when I fired this thing up like 5 minutes ago, I'm immediately pulling from a stream of data and kind of building my own data frame. It's kind of similar to a database in ways, but it's all in memory. So if the moment I close this down, all of this is forgotten. If I chose to persist it or reroute this data into CSV or another database in my like main Python code, that's totally possible to just take the data frame and park it somewhere. But in terms of this, there's nothing permanent. Like this is just all instantiated when I basically launch this Bokeh server. But yeah, that's kind of like the broad overview of this.
That's actually pretty neat. And like, you mentioned that the what you have is just a Python source code, and from there you have like an MQTT library that connects to a Solace broker, and the Solace broker kind of publishes events on a particular topic, and you have your MQTT client from a Python side kind of subscribing to this topic, and any of the events that are coming in, you're immediately processing this event. Is that correct?
Yeah, that's right. So every single event that comes in is being appended, or every single message that we get is triggering an append onto the data frame.
Okay.
The charts and stuff are on a separate update loop that goes about every half a second to get most recent data. So if, for instance, I think for most of these taxis, they push about every half a second to 1 second. But if it was coming in like every 10th of a second, we could like tighten that loop to like a much faster refresh rate. So it can really vary on use case. But yeah, we're not missing any data coming in from Solace with the event-driven thing, because I can just immediately tack on this very small parcel of message data to the data frame.
Yeah, that is pretty cool. And like, I wanna kind of like focus on a particular thing you mentioned. So you mentioned data frames, right? So this is like, can you like highlight a little bit more on a data frame side of things? Because you mentioned that the data that is coming in is not stored in a database. It's not statically available in a database, and your Python code is not reading from a database. Instead, what you're doing is you're getting a stream of data and putting it in data frames. What are data frames from a Python perspective?
So at a high level, a data frame is very much like a SQL database. So it's got columns and rows. So kind of what's going on I guess like a data frame is basically just a SQL table in like a very crude sense, just stored in memory entirely.
Right.
So what we're doing is we're taking the messages the taxis are sending are in JSON format. So what we're doing is we're using just a Python JSON attachment. I think it's a default library. But you can decompose that into a Python dictionary, which is almost the same thing. And then you can quickly convert it into a Python. You can quickly append it or convert it into a Python data frame, because you essentially just make the columns of it the dictionary keys. So you can immediately just take JSON files, turn them into dictionaries, and then append them to the data frame.
And that is all in memory, which is pretty neat, to be honest. Yeah, no, that's great. And I know you mentioned a comment that you didn't write any JavaScript for the front end aspect. One question that is coming from YouTube is, what library are you using to display the charts, and how was that implemented from a library perspective?
Right. So the library to do this, to go from Python immediately to JavaScript without writing JavaScript, I believe there's a couple. The one I chose to use for this was Bokeh. It is pronounced, or it's spelled Bokeh. Another one that's really popular that I could have also used, I believe, is called dash.plotly.
Yeah, dash.plotly is a famous Python library that does the graphs from Python to JavaScript. Yeah,
so Bokeh is really, really customizable, whereas Dash is a lot easier to use out of the box. I think either would have worked for this. But yeah, you can write JavaScript inserts and little snippets to like throw into Bokeh, but for this demo, I didn't have to do any of that. There are ways to kind of like crudely recreate CSS in here, like adding, there's like spacer objects and these kind of layout templates. But for this example, it was basically just, they have like these row and column objects.
Right.
It's worth looking into if you're into trying to visualize any Python work, because it's pretty fast instead of writing all your JavaScript. I'm not a JavaScript wizard, so this was great. So
yeah, and that's pretty neat. Like if someone who is doing a lot of work from a Python perspective, and after doing the analysis in Python, you want to have something like really quick and handy, then these libraries are pretty cool. I'm gonna look up at these libraries, the bokeh and the other library that you mentioned, which is pretty interesting. People are asking, is the code available on GitHub? Are you going to be open sourcing this code, or so far you're just like working on it locally and seeing where this is going to go next?
The prototype is, we're kind of like wrapping it up on Friday. I'll probably have it open source on Friday, and I'll send a link to it when that happens. Currently, this is just local, not super well maintained on GitHub yet, but it'll be up there eventually.
Yeah, and once it's open source, I will be updating our Solace community with the link that you send me for any GitHub repo, and then we could have people from the community as well contributing to this repo and making it much more kind of beefing it up. Couple questions on your screen. So you have some KPIs as well. What are those KPIs and like the real-time aspects of the KPIs?
Yeah, so a couple of these are pretty self-explanatory. So this is the current number of drivers on the road.
Right.
This guy is the current number of en route taxis. The kind of strange issue with this one is I don't know if the taxi company or the drivers were updating their actual ride status correctly, because you'd expect this to be a little more of an even split. I'm assuming en route means they have, based on the number, I'm assuming it just means they're online. I think the other category is called drop off, and I think that actually might just be not them dropping off a passenger, but dropping off the taxi at the end of a shift. But I'm not entirely sure. But
okay,
I kind of expected this number to be more different than it is. But it's basically all of these taxis are assigned to, I think that's the one drop off right here. Yeah, he's over here. Everyone else is en route.
Yeah.
But anyway, this one right here is basically just the average speed of all taxis on a rolling 1 minute average, and then this guy is the current number of passengers across all taxis. With like over time, if I have to refine this more, you can actually do callbacks without having to write JavaScript either, because the bokeh library has a Python way to do that for you.
Nice.
You can add ways to, like, if I clicked on this taxi, I could probably update these to all be specific to that taxi using the bokeh system of column data sources connecting to the data frame, but it's currently not implemented. But it's definitely possible to have a callback where if I clicked on this taxi, these would update to just that taxi's specific things. I guess that wouldn't do anything, but these could also update. But yeah, totally doable.
Yeah, no, that's pretty neat. And kind of like the main difference between like a real-time data analytics and a traditional static data analytics using like a BI tool, I think from my perspective, is having the ability of doing like a windowed statistics, having like the windowed averages or windowed or like real-time KPIs, and having the ability of windowing your average over a particular period of time. This is something that you can do from a real-time data analytics, because the concept of windowed statistics for a static data source might not be as intuitive as, because like your data is already existing in the database. You wouldn't want to do windowed if the data is not moving, unless you have like other use cases for it.
Yeah, it's definitely useful to have kind of a windowed approach to streaming, because at least even for this demo, where it's kind of like a pretty well maintained source of incoming taxi data, you can definitely get messages dropping or like being lost. If say these taxis were like streaming data from like a transmitter, you could definitely have dropped messages, and you definitely want windowed aggregation versus just statically grabbing the last thing that they sent you.
Right. Okay, perfect. Well, I think that was great, Daniel. So thanks for this demo, and at least like this definitely triggers some thinking when it comes to dealing with real-time data analytics. And that was pretty neat. I definitely learned a lot from a Python perspective, and being able to create those visualizations and graphs just purely from Python without really interacting with JavaScript. So this is something that is pretty cool to know. Yeah, so I think that's pretty much it. Is there anything else you wanted to add, Daniel?
No, that's pretty much it. If you're like me and you're kind of like a Python backend slave and you need to whip up a presentation, I would definitely recommend the Bokeh library. So
Yeah.
it made my life really easy. That's about it.
Perfect. So thanks for that. And speaking of Python, I know you used MQTT to connect to our Solace broker. We did release a new Python API at Solace where you can connect to the Solace broker natively through Python, and you could like get the stream of data. This Python API is an early access, so feel free to join our Solace community, and I will be showing you where exactly you'll be getting these APIs. In the meantime, if you have any follow-up questions for Daniel, feel free to put it in the community thread over here, and I will make sure Daniel will get these questions. Other than that, on our Solace community, you can see that we have a Python. If you search for Python, we have a Python API that we just released, and you could go in there and have access to the group and download the Python API. What Daniel just did, just used an open standard messaging API, which is MQTT, and connected to the Solace broker with this. So Daniel, thank you very much for this. I greatly appreciate your inputs into getting this demo. So yeah, thanks a lot. So you could stick around in the backstage or come watch us live on YouTube. But I will be touching base with you after and giving you your swag bag, a solid swag bag for joining us in this event. So thanks again, and we will be seeing you later.
Great. Thanks for having me.
All right. Thank you.